All right, here it goes. Let me see if this is working. New camera setup this week, so we'll see how it goes. This is one big test. I'm gonna pop out the chat, and hopefully we will get some audio and some video very shortly, and then we can roll. All right, let's see if this is working. It's working. My audio here. All right, I think we're good. Hope you're doing well. I'm just figuring out my setup here. I'm a newbie. But this week we're going to be talking about USB CDC, setting up a UART device as requested by the community, which is cool. And also making sure that we're disabling. For another question came in, was talking about how he wanted to disable any type of flow control because he didn't have the pins for it. So both of those subjects near and dear to my heart, and we'll be going into that today. So if you haven't already, please subscribe, hit that like button, and leave a comment. Really appreciate all the comments and questions that come in during the week. Some of them I can't really answer immediately because some of them are like, how do I implement this thing with this certain thing with this other thing, and I need it tomorrow. It's like, but for simple things, just like the things in this video, we'll be going over them, and hopefully they'll be helpful for you. So, but yeah, I really appreciate being here. So, first up, how to disable flow control in Zephyr, and we'll be speaking specifically to an NRF52 from Nordic, and this is from Shane. So Shane sent this a couple days ago. I was like, that's a good one. Let's talk about it. So flow control, it's great for higher speeds. There's like less errors with UART if you have that flow control in place. Not to say that it's not impossible to get them, but it really does help with that. But big thing is if you don't have flow, or if you don't have the pins, then you can't use flow control. So we got to get rid of those pins. And in some cases, you might be enabled by default, and this is something you have to like figure out and look at the device tree and see what's going on with your particular board, whether or not it needs to be enabled, disabled, so on and so forth. So one thing that we can do is just disable it in a device tree overlay, and we'll be jumping into that right now. Jump this guy back out. So this is the overlay from the NR52832 DK in Zephyr, which is on like kind of the main tree there. And you can see it has the RTS pin, CTS pin. Actually, I modified this to add the hardware flow control, just to show you like, okay, this is turned on by default. This is no good. And pause that. So one thing that you can do is you actually can delete these properties, and that'll basically tell Zephyr, hey, I don't need these. Get rid of them. I don't want to set them. It's not necessary. So that's what we can do here. We can use the delete property command, and this will just remove it completely. Now, one thing that's important to note is that in UART or in any overlay, it needs to be set in your device tree for you to be able to remove it. So you might get errors or warnings if it doesn't exist. So if you're doing this at the device level, just don't include the definitions at all. But if they're there, then you can use the delete property command to actually remove them altogether, or remove them if they already are set and you don't want to do anything with your device tree, or you can't really control that. Just the most important part is that the RTS and the CTS lines, they can be set. But if you have the hardware flow control enabled in the device tree, like I just said here, then you have to make sure that that's completely removed. That's the ticket. That's the one that's actually going to determine whether or not your setup is going to be using RTS or CTS, or device or hardware flow control. Also, removing those RTS and CTS pins I wrote RTC, but RTS pins, RTS, CTS, those pins would be allocated. Maybe it really depends on the application layer, whether or not it's actually set. But I would just remove them altogether. That way you can use those pins for something else, and there's not going to be any weird collisions in the hardware or firmware. Just an option and something to keep in mind. So, and everything else is handled in Zephyr, so you don't have to do anything. By setting those few parameters in that overlay, you have flow control turned on or flow control turned off. It's awesome, right? Now, next question is, can you make a video about USB CDC usage in Zephyr? So, USB CDC allows you to emulate a serial port if you'd like. I know there's ways of doing it where you can just talk directly over USB over certain other protocols. It's really up to you and how you'd like to do things, but for this purpose is where we want a USB to UART bridge essentially into the device where you can actually use it as a console. You can also use it with a shell. So if you have a shell in your application, that is another option that you can do, is set up you can enable the shell parameter, and then you could write and read commands right to your device over USB, which is fantastic. I've actually been using the shell a lot more recently. I didn't really get into it. It does take up a bunch of space, so if you have a space-constrained project, you're probably not going to want to use that shell. But for anything else, it's actually kind of nice, and you can actually create your own shell commands and kind of inject them into your code, and all of a sudden you have these custom application-specific shell commands, which is great because like for certain projects on the NRF 9160 Feather I have over here, I'm doing some provisioning over USB. I want it to be set up completely, ready to go, and just like one swipe. I don't need to install any other firmware. It's all from the same firmware. It can be provisioned from that firmware, and it also stays fairly low power, which is great. So, but yeah, we can definitely talk about setting that up in the NR52. I actually have when I talked about this and in my Zephyr talk, I actually enabled some USB CDC stuff for that, just so I could test it out, because I was using it before kind of for console-y debuggy things, but it wasn't working 100% right. So in this case, I've worked out all the kinks and was able to get it working on the air quality wing setup that I had before. So, so yeah, the NR52840 has USB interface. That means you can connect and disconnect as needed. Emulate the UART port, which is kind of what we're focusing on here. And the other thing you can do is kind of redirect the console and the shell to the USB. So that's particularly great because you don't need another UART interface to do that. You can use USB. So here's the setup and the configuration. There's a bunch of things going on here. On the top there, you have the USB, just generally enabling USB device stack, changing the name. Enabling the UART console is probably the more important one, just to make sure that you have the console enabled. There's also this default on like the device name, and that's just something that you can either set in the overlay or set here. There's some weird overlap with USB that I've noticed, and in the next couple of slides, actually we'll talk about kind of the things that you can do. You can actually set up the overlay where you have a little bit more control over how that USB UART interface is actually working. And that is kind of one way, or you kind of just set it up this way, and it's kind of the same default. So you got some control, which is really nice. But the important part here, if you see me highlighting, is the UART interrupt driven flag needs to be set. So that is something important that just needs USB will not work with UART, the UART emulation if you do that. And the line control buddy, I believe, needs to be enabled as well. So those last two are important. And if you're using UART in anywhere else in your application, it will create some conflicts. So we will go over that also in the next slide. So here is the setup for. So I'm using a UART powered PM 2.5 sensor, and the big thing here is I'm using the async API for that. So if you turn up interrupt driven and you turn on the async API, they could conflict with each other depending on what other systems you're using it. So depending on, like, for instance, the console could use polling, it could use interrupt driven, it could use the async API depending on what's enabled in your application. So in this case, we want the USB stuff to be interrupt driven, let that be its thing. But we're using the async API for the sensor stuff. So we have to make sure that on UART 0, it's set to interrupt driven is turned off completely, and that will allow us to run both harmoniously in different modes harmoniously without any problems. So that's one gotcha that I've ran into in the past where it's like, why? But once you find it out, it's just like you remember, and then you put it in there the next time you do an application. So, so this is what was put in by default in the NR52, or actually the Particle Xenon, which is an NR52840 based board. It's not manufactured anymore, but I have tons of them around here. So it's a great board just for messing around. You can also get the Adafruit NR52840 feather wing or feather, which is also basically the same thing. But you can see the defaults here just set. You don't have to really do anything, which is nice. There's also, so this is what I was explaining about in the kind of giving more control, is you can actually define that ACM UART and set it to the compatible device binding. Create that label. You saw that label. It's the same label that was set in the configuration as before. And this will give us a little bit more explicit control over the USB UART interface. So you can actually remap that and make sure it goes to the shell and make sure it goes to MCU boot and MCU manager and the console. Or you could select different ones for different things. So you could actually set up, maybe you want to use a different, like a UART interface, dedicated UART interface for the shell, for whatever reason. And then the console output can go out to USB. So this gives you a little bit more control. And you'll see in a second, if I skip forward, you can see that, like, I've defined it in the chosen. This would be in an overlay if you wanted to, if you're overwriting, saying, those original defaults. Or if you're in a device tree, you can always just set it by default, especially if it's your own board. But you can see here, we're setting the UART 0, the CDC UART 0 for all of these guys. And that's what's going to happen. It's going to get piped out into your USB device. And it just works magically. Thanks, Zephyr. One thing that you have to do in your code, though, is you need to make sure that you enable USB. I've wrapped this in a macro, just if it's not enabled, then I don't want to do anything with it. But that's just one more gotcha in your C code if you have older versions of Zephyr. So if you have a newer version of Zephyr, they actually give you a configuration variable which you can just set to yes, and it'll automatically initialize Bluetooth on setup, which is great. And that is actually the next slide. You can see just config USB device initialize at boot. Older versions of Zephyr, older versions of NCS will complain because this value does not exist. I believe there's some incompatibility. So proceed with caution, but either way, you're going to have to enable it in your code, or you can set the automatic initialization configuration variable, and either one will work. Some extra credit here. So anytime you want something to be low power, you just want to make sure that you have the power management module enabled, and that PM_device configuration variable is also very important. This guy is the one that actually enables a lot of the power saving code on Zephyr, so it allows you to save a lot of, turn off peripherals, put things in certain states where they're as low power as possible. Nordic does a great job with this in their in the hardware application layer, and that's just something you just gotta keep in mind. It's like, okay, this is for low power. I want to make sure that the PM stuff is enabled. This is also great for the USB. I think by default the USB kind of goes into a pretty good low power state when it's disconnected. Nothing's running off of it, but turning on PM device helps in a lot of cases. There are some outlying things you just got to keep in mind. This is particularly for the NR52 series that I've run into, and it's something that I've seen talked about. Actually, Martin from Goliath, he wrote some stuff a while back to allow the GPIO module or GPIO peripheral in the NR52 actually draws a ton of current when you're using it. So if you are using any type of GPIO interrupts, you actually have to switch the mode to a low power interrupt mode, which will drop it from like 400 microamps down to like a microamp. So those are little trickeries and some other things that I noticed for the NR52 while we're talking about it. Any pins that are allocated to some other function, so the NFC pins are by default set up for NFC. So if you're ever running with an NR52 device and you're trying to use those pins for something else, there's actually a configuration variable to turn that functionality off to allow you to use it as a GPIO. Same thing with the reset pin, pin 18, and it's like port 0, pin 18. That is the reset pin. By default, it is the reset pin. So that's just something you need to turn off and to allow you to use it as a GPIO. That particular pin does have a built-in pull-up, which you can't disable. So if you're running on any type of low power, I would avoid using that pin for anything really if you can. If you need to, do it with something that's going to be default high, logic high. So then you don't kind of run into the costs of having that pull up there. Those are the kind of gotchas in the hardware in terms of Zephyr and power savings, but you kind of learn as you go, and those always bite me. I've been using these devices for a really long time, and I always seem to forget about those pins. It's like, I gotta switch these. We'll jump over here. So for USB, it's kind of great because it's, there's only a couple things you need to do to get it working. You just got to make sure the overlay / your device tree is configured and calling that USB enable function, or setting up that configuration variable depending on the version of Zephyr / NCS you have. And like I said, the different flavors of Zephyr, you might yield different results, or some configuration variables might be there versus others. Nordic has been on a pretty good release schedule, so they try to keep everything in sync, which is really great, but sometimes they make really big breaking changes. Like they just made some big breaking changes in version 2 of NCS. So for people who have been working on applications up to 1.9.1, they're kind of hosed. Some of them use some of the different technologies inside the NRF91 in particular. So I haven't spent a lot of time diving in to see how I can kind of do an OTA, but it might not be so straightforward. We'll see. And I'll just jump into a quick demo. So this is the setup actually running here, and you can see that let me see if it's actually updating. Is this the wrong window? Dun, 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 dun. Yeah. Nope, don't want that one. And then, cool. So you can see, like I was looking at the PM device just to see where it was enabled. I think when you enable PM device, it'll also enable the power management APIs, which is nice. And so serial monitor. So this guy is actually set up before. I think you probably saw it. That was kind of spitting out some output. And the cool thing is, especially if you have a system where it's low power, or maybe it's something you're only going to be using sparingly, all that power management stuff is really handy because that gets enabled and disabled, and your application still remains pretty power optimized, which is great. So I can completely disconnect this thing, I can plug it back in, and it'll kind of reconnect, and it'll kind of reset up again, and it'll start grabbing new data. But this is all over USB. I mean, I'll show you. It's all plugged in. That's the only thing that's plugged into it. So I'll bring it out here. But it's great. It gives you just another option if you don't want to deal with UART or having extra dongles or whatever. Like if you have a USB port and it's already wired into those USB pins, like why not? It's already there. Why not take advantage of it, right? So yeah, that's it for today. I really appreciate being here. Let me see if there are any questions. And I don't see any questions. But if y'all have any questions, feel free to throw them into the chat box before I take off. Cool. Doesn't look like there's any questions. But really appreciate you being here. Thanks again for the input and everything for all these questions that come from the community. So I really like going through them because some of them are ones that I've run into where it's just like, this is terrible. Why is this not working? And then you change one configuration variable and then magically it's working. So yeah, so if you have any questions for next week, shoot them my way and we'll see you then.